Hey YouTube, Jay Kilroy here with part 2 of the ongoing Fogless Mr. Saga. The good, the bad, and the ugly. The good. I don't know if you can hear that, but the Fogless Mr. is working. The bad. These little expensive needle valves are junk. These might be fine for a laboratory environment, but for a shop you need something a little more heavy duty, and because this is soldered in, as you know, swapping this is going to suck. So I suggest going with a threaded mounted needle valve. One of those big clunky gas ones from Home Depot will work fine. Other upsides, this polyurethane hose from MasterCard, I have the part number in the description of the last video. This stuff's tough as nails. I suggest pliers for cutting it, or an extremely sharp knife. It's rugged stuff. Anyway, let's move on to the setup here as it stands right now. It will change. Let me get the camera and we're going to go around there and examine how I got it set up. Okay, here we are. Pardon the mess. I haven't got it all plumbed the way I want. See here, I've got one of my main feeds coming down from the ceiling. Down this, this is a DOT approved air brake line into a drop here. Got a ball valve there. Comes down to a little filter separator here to a dual connection press fitting. And then this is 1/4 inch nylon tube. One of them comes into the this is the actual gauge for the regulator that's pressurizing the coolant canister. And let's cut that back some. And then I've got a General Electric water filter canister here, if you can read this, GXWH20S. This is a big box store deal. Obviously it came with 3/4 inch fittings. Pardon the cluster of fittings, but this is what I had in my box. A filter housing that took a 1/4 inch pipe would be more effective. Of course, this one's pretty neat in that it has a valve. It has a bypass valve. So right now, you can see in the canister I had a couple old bottles of LPS Aqua Cut, so I dumped that in there. It's water based. And then here's the coolant coming out of this hose here. Here's the air. This is the air pressure regulator. I haven't figured out how I want to mount that yet. I've got it set to about 15. Let's cut that back to about 10 here. And then the combined hose comes over to the unit. And here's right now the needle valve is closed, so there's nothing, there's just air coming out. One of the cool things about this thing here is if you put it on bypass, like so, you get nothing but air, right? Out of both sides of the coolant nozzle. You leave it on filter, then you get coolant. What I did in here, I've got a little 1/4 pipe to 1/4 compression fitting in the hole that normally took the water out of the filter. Then I got another piece of 1/4 inch nylon going down into here as a pickup tube. And it works pretty darn good. Let me get the camera set up a little more stable, and then we can show you some coolant coming out of the nozzle. Alright, I'm going to try to set up here over a background, a dark background, to see if I can show you some spray patterns, and I can adjust the needle valve, and I can show you some various spray patterns out of the mister here. Let me get set up. Alright. I'm going to close the needle valve. There we go, it's closed. You can probably hear the sputtering stop. That's 15 psi of air right there. No coolant. Coolant tank is pressurized to about 20. Now I'm going to, hold a sec. Alright, sorry about that. The coolant nozzle, the coolant's off, and I'm just going to start turning it up here a little bit. Now that right there, barely open. And you can definitely tell when you introduce coolant into the stream, it definitely gets cold. Now if you increase the flow, even that right there, even though that's a fair amount of coolant coming out of my hand, it doesn't really make a fog or a mist per se. I mean, it seems to work pretty darn well. It gets my hand wet, but I'm not bathing in a cloud here. If you continue to open it, you can see that there. It'll definitely put some coolant out. So anyway, mission accomplished on that front. Let me clean up here real quick. Okay, YouTube. The coolant system works, and I'm sure there's going to be a lot of playing around with. I think I'm going to play around with some different MIG tips and play around with different pressures on both the water, the coolant, and the air side, and play with that. Got to replace this busted needle valve. Got to get me a needle valve to replace that and modify this block to take a more robust needle valve. Like I said, forget those little dinky needle valves. They're not real stable. One of the things that I'm not pleased with the system about, and I'm going to have to correct, is while you can adjust the needle valve locally to cut off coolant flow, I don't have anything right here at the block or right here at the front of the mill to allow me to cut off airflow. That's a problem. I have to walk over to where the coolant dispenser is mounted, there next to the mill, the column of the mill, to turn the valve to cut off the airflow. And that's not going to work out long term. I mean, it works, but it's just kind of a pain. So I got some old 12-volt solenoids left over from another job that I think I'm going to rig into the air supply so that I can put something up here on my regular electrical panel for the mill, so that I can control the air supply to both the coolant side and the air only side electrically from the front of the mill. And it's usable the way it is, but long term I just know I'm not going to be happy with it. As far as mounting goes, it was an astute observer noticed that I did not drill the mounting holes in the block here. And I did not, and I can tell you why. Because I've decided that I want to mill the bottom of the mounting block here, the bottom of the long side, if you look on the drawing, for a dovetail to mount it similar to an indicator. This is a little compact brand indicator, and this is something that you're all familiar with, the indicator dovetail mount. I want to mill these to have a dovetail on them as well, so that I can mount them in Noga style arm from the bottom, like so. I think that's going to be the most generally effective. So we're going to do that next. I don't know if I'll put it into this video or put it in another video, but we're going to mill these little slots, and then I'm going to have to get a more robust needle valve. But in general, the fogless system is fogless. It does, if the coolant that you have in there has a scent, like some of the coolants have an additive. Obviously, you can smell it, but it certainly doesn't cloud the place up. So I'll actually set it up on the mill, and then we'll use the mill to mill the dovetails here on the bottom of this block, and we'll use the coolant system while we do it, so that you can see it in action working on this block, and we'll do that here right quick. So let's go ahead and get set up to cut the dovetail on the bottom of this. Alright, we got our block here with the bad needle valve, the now gone needle valve, back in here. I had to take the fitting out of the back. Got a little 60-degree milling dovetail cutter here in the mill, a 3/8 inch collet. And we're going to cut the dovetail that goes on an indicator here on the back of this block. The depth in that dovetail is 1.6 millimeters, and it is a 60-degree dovetail, so I do have the right cutter in there. And if you measure the width, I'm not getting out. If you just measure the width across the points on the dovetail, it is about 233 thou across the width of that dovetail. So what I'm going to do is I'm going to take my calipers, I'm going to clamp across the points on that dovetail, I'm going to zero it, so now I have that width. I've got my cutter here touching the top of the block. I'm going to back off using my quill DRO. I'm going to lower my cutter 1.6 millimeters. Close thereabouts. Alright. This definitely doesn't have to be super precise. And then we're going to go ahead and take a cut until we're full depth here on the back side. Then we're going to measure, come around this front side. We're going to take another cut across here, measure across the points, figure out the difference between our initial cut and then the 0.233 is our target, and then we will adjust our Y and take a final cut. I'm not really concerned about the dovetail being in the center of the block. Doesn't matter from a functionality perspective, so I'm just not even going to worry about that. Now we're going to use the coolant system, which is set up here while we're doing this cut. And let me go ahead and get it cranked up, and we'll start cutting some brass. All right, we're running about 700 RPM. Alright, got a full depth cut here on the back side. Now we're going to come around to we're going to go ahead and offset, come around to the front. We'll be cutting from the other side, obviously. Whoops. Sorry about that. Ran into my camera with my quill. DRO. That would have been funny there for me to make a comment about how little air it was using and then have my compressor kick off. So anyway, we've got a full depth cut on the back. We're going to go ahead and take a cut across here until we're cutting a full point, and then we're going to take a measurement and offset to our target dimension. Again, we're going to leave the RPM about the same. Just walking over to cut off the air is not going to cut it. So we've got our point-to-point cut here. I'm already zeroed on my target dimension. Measure across here. I'm still big by quite a bit, by 138. So I'm going to zero my Y here and just start chewing away at that 138 until I get close. Let's do that. Alright, let's check our dimensions in. Alright, that baby's in there. We got that dimension, like I said, we got it cut there. The dovetail in the back. I'm going to go ahead and dismount this and mount it into a dovetail style holder, just as a little demo of how this thing's going to work. Alrighty. Here is the block now. A little dovetail cut on the bottom. And sliding in here this is the arm that I normally use for my camera, so using something else for my camera, but it's handy. The little fine adjust is pretty nice. I mean, it allows you to help aim. I've got to, like I said, I've got to replace the needle valve. I suggest you go with rugged needle valves, not these little laboratory deals. Of course, you could drill the orifice for the needle valve and just tap the block directly. That's something to look at. Where's that little needle valve at? Still have that. There we go. Let's see. Yeah, I don't think I have a tap that small, that fine. I don't think I have a, what is that? That's got to be like 40 threads per inch or more. So, well, so much for that idea. Anyway, this is part 2 of the fogless misting system. It works. It will apply coolant from a stingy, tiny, you can't hardly tell drizzle to a full-on monsoon, and it is rather economical on coolant and air. So part 3, we're going to get this needle valve fixed. We're also going to look at getting some solenoids hooked up on this system. Here are the solenoids that are left over from a job that I did quite a while ago. These are little Takasago electric, some Japanese made product, and they're a little 12-volt solenoids with a 1/4-inch pipe attachment. And so I'm thinking I'm going to rig up some of these solenoids to do the air, and so that I can have easier access to triggering the coolant system from the front of the mill without having to walk around the back of the mill. So that's what we got coming up. Stay safe in the shop, and I'll talk to you soon.